So good afternoon. I'm Simon Daniel, founder of a British company called Moixa, and we design software to try and manage the world's batteries and support the energy transition. I want to share today some of the examples of how we use this to control batteries in homes and electric vehicle charging to form large-scale virtual power plants. And I also want to talk a bit about some of the funding challenges the world has to enable this transition to net zero. It's pretty obvious that the world has changed this year. And what's interesting, despite the trauma of COVID, is we've seen a 7% fall as an unmanaged net zero, creating a lot of economic damage. But the bigger challenge the world faces is we need a 7% reduction in carbon every year in a managed transition without wrecking the economy. And therefore, the role of digital technologies, which are fast, as well as financial innovation for infrastructure, we believe is very important. Overall, the world has a number of sustainable development goals. And one particularly interesting way to look at these goals from the Stockholm and Exponential team in Sweden is that we need to halve carbon every decade in order to hit this target of net zero. And so, whilst it's quite an ambitious challenge, how do we reduce to net zero today? But how can we get there every decade by trying to halve carbon through technologies in renewable energy, through electrification of mobility, and then significant improvements in our household infrastructure? And this is a really significant challenge. And interestingly, technology, both from the digital side, is on track to support the transition in energy and transport, particularly with the recent goals to ban petrol-based cars from 2030. We believe to enable this transition, batteries lie at the heart. Renewable energy is fantastic, but it is intermittent. The UK has around a third of its energy coming from renewable sources today and is on track with new wind and solar investments to achieve nearly 2/3 within the decade. However, the sun doesn't shine at night and wind doesn't always blow. And the UK as an island gets 95% of its electricity locally. And that creates a significant challenge when renewable energy is in short supply, which is where the role of storage becomes critical to get rid of peak fossil fuel plants. And this is storage in homes, it's storage in vehicles, batteries with wheels. And interestingly, worldwide, there is projected to be 250 million vehicles by 2030. And this will be tens of terawatt hours of batteries costing trillions of pounds. And that forms a kind of virtual storage reserve. As an example, in the UK, the Genoric pumped hydro plant is an 8 gigawatt hour storage facility, and we can't flood the rest of the country with similar scale. But there's around 8 gigawatt hours of batteries today in the UK car fleet, and that's set to rise to 800 gigawatt hours as we go for more larger scale electrification in the UK. So the role of managing batteries using digital technologies to store and shift solar, maybe linked to time of use pricing and get rid of peak challenges, is significant. At Moixa, we've got a lot of experience in doing that in home batteries, in using our software to control large fleets of batteries, notably in Japan, which is also an energy island, and looks to the UK, for example, of regulatory policy and technology. And we're now starting to apply our technology to controlling when fleets of electric vehicles charge. As if everyone has an electric vehicle and they charge at peak time, the UK infrastructure would need to grow by 3- or 4-fold. And where we deploy our technologies, both in physical batteries using digital information to share energy use profiles to the household, and to automate and optimize when batteries charge to local solar resources, or to avoid peak times, and to learn about the consumption of energy in the home. So we use a variety of energy technologies. This is an example of Internet of Things to connecting devices using AI machine learning to manage the optimization of these assets. But we can also use the software to group together large fleets of assets so they can be managed together as a collective resource, kind of like a monster battery, by grouping all of these things together and telling them when to charge or discharge. And the same technology applies to managing when cars charge and discharge, and doing that at a time of low carbon supply and to avoid times of high peak demand. And Mike's had a lot of experience, a lot of it supported by the British government in demonstrating technologies across household projects and now into vehicles with UPS, for example, and also in Japan. Now, if I look at Japan as an example, we've now deployed connections to around 25,000 batteries in homes in Japan. This is around a quarter of a gigawatt hour of storage. It's the largest managed fleet of household batteries in the world. And by grouping these together, we can effectively turn on and off a kind of virtual power plant. And this is doubling every 6 months. So soon we'll be able to use digital technologies to control gigawatt hours of power in consumer homes, kind of like a virtual Hinkley or virtual nuclear power plant. And this is being done by connecting assets bought by consumers or owned by others. And this is where some of the ideas in the last presentation of heat as a service become interesting, because like with something like Uber, if you start sharing these kind of resources such that other people can use them when you're not at home, or that wind farms can put their energy into your batteries, that becomes a kind of collective shared infrastructure and becomes a very important example of how the infrastructure of the future cities will work. Now, I look at this, for example, over a day, we can see how homes pull power from the solar, store them in the battery, and use off-peak charging at low cost to charge up for the next day. We get a lot of insight about how households behave. And certainly over the COVID transition this year, we've seen a shift in our domestic customers in the UK and also in Japan about household behavior. People are not traveling as much. They're working from home, and the energy peaks has therefore moved part of the day, and overall energy consumption has dropped in certain sectors. And we can then probe this information to work out patterns of behavior in order to optimize when batteries charge and discharge, to learn a lot more about characteristics, as the previous speakers demonstrated in the heat. We're learning about the electricity demand. We're also learning about the mobile demand of when vehicles are being used seasonally. And by grouping things together, we can do a form of demand response by turning up certain charge events and turning down. And this has a sort of effect of creating a virtual power plant, because if I have connected, let's say, 1 million vehicles and control several gigawatts of power, rather than turn on a new power plant, I can turn off or delay charging on a managed basis. And that can help flatten and manage the overall infrastructure. And ultimately, that saves a lot of infrastructure money in building extra wires in the ground or building extra capacity in the grid, by trying to make the capacity which is there work together as a form of shared asset. But our view, the overall energy transition needs a lot of connection. And so we're using some of the digital approaches, and we call our platform GridShare, to make these distributed assets behave as a form of infrastructure and access new value. We're helping households or batteries in cars share their capacity and work with energy suppliers to work out when's the best time to charge and discharge a battery resource, helping their economics and their customer retention. And then we're sharing this resource upstream to help network operators use these resources to manage constraints on the network. And then collectively, if I aggregate further upstream, the grid can also use these resources to balance overall demand of wind and solar across the nation. And so we've demonstrated using technology in Japan that this notion of virtual power plants, which has been a theory for some time, does actually work. We can control large groups of houses in a way that the house gets the benefit of its product, but also can share its spare capacity upstream to the grid to help participate in a shared infrastructure. But the overall economy needs a significant reset in order to hit net zero. We need to look backwards from the target of net zero and look at how the world is going to be different. And the last speaker referred to new business models, and the as a service business model is something which has been growing significantly in the last few years. We receive many things today as a service, from originally healthcare through now to Netflix, and now also soon with transport as a service through Uber and other kinds of models. So we think that new business model is going to be one of the things which will continue to grow through the next next few decades. 2050 isn't so much a money economy, it's a service economy, it's a digital economy. We no longer own some of the assets, we kind of lease or have shared assets. And as a result, one needs less assets. If I go back 30, 40 years ago, most homes would have bought a lawnmower and tools and DIY equipment Do we need to do that today? If we can press a button on our phone and effectively that tool will arrive with a digital delivery from Amazon or from Ocado, then we need less products. They're used more efficiently and shared. A car today is used 5% of the time. An autonomous vehicle would be used most of the time, and therefore the carbon going into that product will be shared and make the infrastructure more efficient. But trillions of pounds are needed to turn this current world's infrastructure into a low carbon infrastructure. At the same time, we need climate recovery, we need COVID recovery and jobs, and we also have an aging infrastructure and aging population. So all of these things need to work together in a joined up approach to build back better. And we do see it as one problem. There are mega needs. All this money is needed today. There's lots of calls on the magic money tree sitting outside number 11. But there are also mega trends in these exponential technologies, these AI, this electrification, and in these new business models of as a service technology. And we've come up with an idea, which we call net zero pensions, to really join together some of the financing obligations. The UK, for example, owes nearly £8 trillion in forward pension liability, and only 2 trillion of that is funded by assets. And the ESG movement to look at sustainable governance in pension and assets is working very well to encourage asset-based finance to head and fund low carbon recovery. But what about the other 6 trillion we don't actually have? Do we fund that by just raising debt and taxing people? Or is there a better way we can raise debt and allocate it to some of the unfunded needs, such as paying our pensioners to heat their homes? And it's interesting, but also somewhat depressing, that to pay an energy bill through retirement, one needs around £35,000 as a lump sum to fund an income stream, historically an annuity, to pay an average energy bill on an annual basis. And most homes don't have £35,000 in a pension pot. So ultimately the government, through the state pension, raises 125 billion a year in taxes and pays 12 billion a year of that out to heat people's homes. And households then go and spend that money on choice for different kinds of energy. And quite often that isn't necessarily a sensible choice. They end up buying non-low carbon energy or leaving their home insulation on all the time. And so is there a better way to organize? If you knew you needed £35,000 to retire and pay energy bill, could you not spend that on energy efficiency? Could you spend it on a solar battery? Could you spend it on an electric vehicle? And so within a model we have is why not invest now in low carbon infrastructure and raise debt and have that paid for by some of the tax obligations in the future to pay pensions for energy and mobility. And instead of paying money, we deliver as a service, whether it's heat, energy, transport, or other things as a service. It's also more efficient to insulate your home than paying a bill. It's better to have a no-bill household than to have money to spend inefficiently in the market. And certain technologies, particularly renewable infrastructure from solar, from wind, through low carbon technologies and batteries and storage and smart grid, are getting very predictable. So you can end up predicting 10 to 20 to 30 years worth of energy service from an asset. And with 1/7 of UK's pension liability ultimately spent on energy, so over £1 trillion of money we don't have will be spent in the future on energy and transport. Why not join together and make this a low carbon infrastructure and have this money raised now to create jobs, to create this transition required to a new low carbon economy, at the same time writing down debt, which we don't have to fund energy and mobility services in retirement. Take it another way. If you imagine today, you need around £50,000 to fund paying an annual cost of a fuel vehicle. Typically around £2,000 is needed for fuel and also taxes and other things. So can you use pension income to buy fuel? Or could you use your pension income to instead buy an electric vehicle, where effectively you're pre-buying your fuel in the battery in a vehicle, and you have therefore low or no cost of ownership going forward? Is it more fun to have an income stream which pays for your fuel, which you then burn, or to drive in your pension? And in a similar way is from infrastructure, UK needs to fund new roads, new transportation, new trains. Interestingly, HS2 is actually a low carbon form of transport, like Eurostar is one of the most efficient potential forms of transport per passenger kilometre at 8 grams of carbon. Should we be investing today in new battery technologies through the Faraday Institute, through new zero carbon air travel? We need to spend a lot of money on that, but if we do it well, that can deliver net zero benefits in transport, in energy, and so forth. So we think there's a powerful rationale behind what's needed is recovery. And with the UK hosting COP26 this year, UK as an innovator in technology, in science and in financial models, does have an opportunity to set a policy, to rethink and reimagine how funding of debt for infrastructure works and funding of retirement, and recognizing some of the opportunities present in the new business models for this cashless as a service future. So in summary, we think digital technologies and financial innovation are essential to deliver a net zero future. The UK has a strong leadership position in its technologies and its innovation in batteries and grids, in AI, in technologies and financial services. And taken together, we think there's a significant opportunity to invest in that today, to create jobs today for a low carbon tomorrow, and to ultimately reduce debt in society. We published a paper recently available at our website called "The Social Responsibility of Nations is to Reduce Debt." And this turns upside down the Friedman notion that companies should just make profit for the stakeholders. Nation states should reduce debt for their citizen. And the most critical debt we have today is to reduce the debt of climate, and then also financial debt and social inequality debt. And we view a strong way to do that is to join these things together to deliver together a low carbon economy. Thank you.
Thank you very much indeed, Simon, for a really rather inspiring talk. I'm just waiting to see if we've got any questions coming in, but we've got one at least anyway. And somebody who's asking about grid inertia, which is critical in grid stability. And are you implementing a virtual inertia with your batteries?
Not directly for the immediate fast frequency. Delaying a battery charge can help frequency response management. So certainly that is one of the many services you can deliver. And I think, definitely with the way the grid is run as a central system, the historic technologies to manage inertia and keep things on standby were really critical. And batteries themselves can respond very, very quickly. And so on a screen, I could turn up or down demand of 100 megawatts in Japan, for example, by pressing a button on my screen. And soon I could turn up or down demand as a gigawatt. And so technology enables me to do that. Now, the latency of doing that through the internet is a few seconds. Whereas if we set a product into a standby mode to look for a frequency event, it can dynamically respond. So definitely, the software becomes critical as you get many, many more things connected. And that becomes also critical to make sure the security standards are there, because certainly there's a lot of power in the distributed technologies. We used to think, for example, if Tesla decides to update all their cars at the same time, or Microsoft used to update all their computers at the same time, and if you've got billions of connected devices, then the companies controlling those devices need to work for the benefit of the system, and also to make sure they've got good coding and security standards in place because of the controls. And what's perhaps maybe more important is the speed of exponential technology means this is just going to happen. The policies will hopefully catch up. But as we've seen with the speed of the internet technologies, the role of connected energy technologies and smart assets is just going to happen. There are certainly price points, as we saw with solar. It took a while for solar to get off the ground from Jimmy Carter putting it on his roof of the White House in the 70s to millions and millions of homes having solar. The price point had to fall significantly. And similarly, the price for electric vehicles needs to fall to enable this. But if the vehicle cost, for example, is shared, because it's also contributing to the energy system, then the product acquisition cost falls, and therefore it's more of a social product than an individual product in the future.
Yeah, so I mean, what do you think needs to be done next to start implementing this net zero pension model, which is a very interesting idea?
Well, I think it's kind of, the UK needs a long-term fiscal strategy and doesn't have any money, and so it needs 300 billion or so of extra debt this year because of COVID. And I think Hammond identified net zero basic would cost £500 billion to hit net zero on the target. And so we've got a problem. We need £500 billion for COVID recovery. We need £500 billion for climate. And we also need £6 trillion in the future for pensioners, whilst we have a falling workforce and an aging population. So we do need to implement something like this. Otherwise, we will have much, much higher taxes on the Greta and millennial generation, which is probably going to be unsustainable. So we think there is a domino, and I've outlined a couple of ideas in our white paper. And I'm not an economist, so I want to seed the ideas of the experts in a room who can move forward on policy innovation. But we view that tax relief and nudging in the private sector, such as should you draw down your pension and put it in a financial product, or should you put it in an energy as service or energy product? Should you put it into your own home to reduce the carbon of your home? Is there a tax relief or a free drawdown to enable that? And certainly historic programs like the Green Deal would have worked had you been able to fund the Green Deal from your own pension pot or defined benefit scheme. And if we demonstrate ideas in the private sector, then the defined benefit sector of the companies has a significant shortfall. It's estimated to be £290 billion is missing from the FTSE index and 7,800 companies in the UK. And with many companies being exposed to potential failure, the pension protection group is underfunded in terms of the pension protection fund. And therefore, we identify of the £2.2 trillion in the UK defined benefit scheme, nearly 300 billion is missing, but 1/7 of that overall money is going to go onto energy and mobility and retirement. So would it not be better for Rolls-Royce or Shell or BT to offer a net zero communications, transport or energy service from the things they already do to their pensioners? And therefore, can rules enable scheme members to opt out of and opt in to a net zero service for a portion of their cash income? So really, it's an exchange. Would you exchange a portion of your cash income from your private or defined benefit or state benefit scheme to receive instead this managed net zero energy? And if you demonstrate well in defined benefit schemes, the impact would be FTSE companies would post a significant gain on their balance sheet by effectively transferring the risk to a managed scheme, as we've seen with the bulk annuity market. And therefore, schemes like the NHS and public schemes, which are also underfunded. The UK owes 1.8 trillion of the national debt in that respect, in the whole of government accounts, is for public sector pensions, and they're only partly funded at the local level. And therefore, future taxation goes to pay that. Whereas future taxation could go to pay the debt on the jobs and the infrastructure created to deliver NHS workers and transport workers their pensions in the future for the energy part. And therefore, if you do it at that level, then the wider state scheme, which is where £4 trillion is underfunded and paid for by future taxation, can also be done that way. So we sort of see a domino effect from the financial sort of awareness in the press through scheme membership rules to then the policy of whether consumers and people retiring would opt into net zero. But stepping back, we have a duty of care as citizens of, do we want to retire into a community where there's planetary issues, or do we want to join a scheme where we're contributing to solving the problem? And the digital technologies are there. The technology innovation and the chemistries, and they're all there. The money's missing unless the policy joins it together. So achieving COP26, achieving net zero, is just a financial problem. And interestingly, we think it also is, by solving the problem, we reduce debt. And so that's the sort of potential with this. It's also quite radical, but it's not unlike, the NHS is a service. And historically, the idea of pensions came from the Middle Ages, where you gave money to the monastery and they gave you food and lodging for life. And we're basically saying today we have an obligation to pay money in the future, but why not allocate a bit of that now to achieve our joint ambitions of a net zero economy?
Thank you, Simon. This is obviously something you're incredibly passionate about. I want to ask you one very quick question. From my perspective as an environmental scientist, and I mean this concept of a virtual power plant, which is based on this amazing network of batteries. How do we? What will be the impact? Is it going to be a good deal for nature, with the need for so many batteries around the world? Because my understanding is that some of the ways in which batteries are constructed and the rare metals they need, that there's a big impact on the environment from mining and extracting those metals.
Yeah, there's certainly, I mean, all things manufactured have a carbon cost in their downstream supply chain. And there's been obviously a lot of recent press, and it's probably interesting to look at where that press has been funded from, pointing out the challenges in the future battery supply chain, let's say, versus the challenges in the historic oil supply chain. And certainly, the most popular chemistries today in lithium and some of those configurations depend on rare earths, which are in short supply. Predominantly, they're also in different geopolitical control. And so there's a challenge there. However, there's a lot of battery innovation going on from the Faraday Institute of the UK and the MIT group. And so in the pipeline are significant amounts of innovation which are rare earth metal free, and also move beyond lithium to sodium, which is more prevalent. And so, the carbon cost of batteries in their life cycle is going to become an important metric, not just the price. And like we saw with solar, if you manufacture something in a low carbon economy, like Europe, like the UK, that has an advantage over manufacturing something in a high carbon energy grid. And so certainly Tesla manufacturing their cars in a low carbon factory with solar on the roof, provided the solar panels are also made in a low carbon infrastructure, is much better than making it in an offshore market.
Yes, I think I'm going to have to.
The carbon factor, therefore, is very relevant into both import and trade and future costs of the lifetime service.
Yes, I mean, we do have to look at the end-to-end cost and the impact on the natural environment of all these things, don't we, as we go forward. Thank you very much, Simon. That was a very thought-provoking talk, and I'm sure I shall go off and read your paper for once.